Alright, Calc, welcome to a quick review video over Wednesday as part of your 2-day exam. Today we're brought to you by Laura Bar, the original fruit and nut bar, and Glade. Nothing kills the smell of a freshman quite like Glade. Plug it in, or use the apple cinnamon spray. Anyway, folks, take the general antiderivative. I think you have 14 of these on your test tomorrow. Get rid of that d theta there. That was an accident. Okay, so that's simply antiderivative of sine is negative cosine, and then instead of multiplying by 3, you're going to divide by 3. All right, plus that constant of integration. On number 2, you should rewrite it as I did there, and then 1 power up divided by the new power. Okay. Pause this whenever you need. That's simply 3 secant x plus c. That one's not given to you. Again, I'm not doing all these, but a bunch of these, folks. Okay. The antiderivative of cosine is just sine, so that negative is going to stay there. I need to divide by 4. That's why I get the negative 1/2 sine 4x plus c. Number 6. Anytime you take the derivative or antiderivative of anything with e, just write down that original function. And instead of multiplying by 1/2, I'm not taking the derivative, I'm doing the antiderivative. I would divide by half. 2 divided by half is 4. All right. This next one, 1 power up, divided by that new power. The antiderivative of negative sine is positive cosine. Nope. Number 9. Again, I'm just going to rewrite that. 1 power up divided by that new power is this. Right here, folks. So really just rewrite those e to the negative 6, e to negative 2, or 6x, e to the negative 2x, e to the 3x, and divide. So don't multiply by negative 6, negative 2, and 3. Divide by those. Don't forget about your constant of integration. Folks really like number 11. Make sure to foil that bad boy up first. Then don't forget to take the antiderivative. All right, this next one here, I should rewrite it as such. Then I should take the antiderivative of each. 1 over x, 2 over x, 3 over x, all has something to do with natural log. I'm going to rewrite 13, then take the antiderivative. 1 power up divided by that new power. Don't forget about the other 2 on the outside. All right. 14 is a good question. Like that one right there. Divide. 16 is very easy. Please do not miss 16. All right. I don't really care about negative exponents. You can leave them. That's fine. 17 could not be easier. Could not be easier. 18, folks. You know, that's really x minus 2 squared times x minus 2. All right. So it's going to simplify to be that. That's just f of x. Then you take the antiderivative. 19, 1 power up divided by the new power. I think you can do that one really quickly. And 20, I'm going to rewrite it. 1 power up divided by the new power. Clean that bad boy up. And would really know those. Okay. Then we're going to skip quite a bit. This is going to be a very quick video. One was not promised to you. So this is just sweet bonus. Acceleration of a particle moving. So if you know a of t is 6t, then you know the antiderivative is the velocity function. I told you that when t is 0, v is 1. So v of 0 is 1. So that's what c is. Take the antiderivative of the velocity function. 1 power up divided by the new power. I told you also that when t is 0, s is 3. So s of 0 is 3, and that's your new c value. There's the position function s of t. The velocity function v of t was that. So if I ask for both, velocity function, position function. Particle moves along a line so that at time t, that's the velocity equation. Find the displacement over time period 1 to 3. It's just the antiderivative. You're going to integrate from 1 to 3, that antiderivative there. And that's some number. Good luck. 60, I think I made a boo-boo on 60 when I gave the answer today. It's really kind of the same question as 58. All right. So just take the antiderivative of what function? That one right there. Take the antiderivative. You know that's at time t is 1, v, the velocity is 36, so 36 is equal to, you get c is 19. That's where I made the mistake. Take the antiderivative. That is 1/3 t to the third. And you know that when t is 1, s of 1 is 21. I think you get negative 20/3 for c. All right. Anyway, just know how to do that. Finishing up here, you're going to integrate again. It's literally the same one as a few questions ago. Going to integrate over 2 to 6 to that function, and then your result follows. Okay, this one's pretty easy, folks. You just simply take the antiderivative. And if v of 0 is 13, that's what c is going to be. V of 0 is 7, that's what c is going to be. All right. F double prime of x. We talked about this one in class. You take the antiderivative. You don't know what f prime of 0 is, so you got to keep going. When you take the antiderivative of a constant, that's just cx plus d. Then you use the fact that f of 0 is 3 to get d is 3. So we're looking at this. And I don't believe, did this one have a boo-boo? This one did have a boo-boo. Right there. All right, then you know that when x is 1, your answer is -2, so plug 1 in, it's -2. I think you get c is -22/3. That's attached to x. That one's a tad harder. I really like 64. I think 64 is pretty good. Maybe rewrite that. That's 2x to the 1/2, 1 power up, divided by that new power. If you know that f prime of 0 is 2, then you know that c is 2. Take the antiderivative of that. Kind of messy. So if you know that f of 1 is 3 when your answer is 3, x is 1. So figure out what c is. All right, and then 65. You know that if f prime of 1, c is 4, so this one actually is 5. We made it a few oopsies here the other day. All right. Anyway, f prime of 1 is 4, so plug 1 in for x, you get 4. C is 2. Take the antiderivative. Let's just make sure you know how to take the antiderivatives. Okay, 5 goes there. When x is 1, plug 1 in for x. You get c is 13/6, I believe. All right, this is anything that could be on part 1. There'll be a short video tomorrow over part 2 stuff. Study, study, study. This is Yak Math Videos signing out.